Thank you. Is this on? Okay. I'm gonna do two things. I'm gonna talk about NSF-related programs that might fund some of the work you've been talking about, and then I'm gonna speak some of my observations from from what I've seen and challenge you, I hope. So, and I'm gonna borrow something that I learned from Alan Cheville, who was a program officer at NSF. So I'm currently wearing my NSF badge. So I'm speaking on behalf of NSF right now in terms of our programs. Then I will take my badge off and speak as I guess the faculty member from the University of Florida, if you will, which is my home institution in environmental engineering sciences. So the NSF programs in engineering education, the overarching framework is called the Professional Formation of Engineers, and NSF program titles get confusing, so I get a lot of programs have the prefix PFE for Professional Formation of Engineers. I get comment requests about the PFE program. PFE is not a program, it's just the overarching framework. But it is the formal and informal processes and value systems by which people become engineers. This quote by Michael Fabre, translated by Gary Downey, I really like it because it really underscores what we mean by the professional formation of engineers. And as a result, it encompasses all aspects of what it means to be an engineer. I was going to say both the technical and the professional. Unfortunately, Don is not here at the moment because it is all engineering. And so all of those pieces are important. If I can figure it out. Okay, here. So what constitutes formation of engineers? Well, it's really broadly speaking, it's anything that you need to be able to do engineering. So it's introductions to the profession at any age, so that my programs go pre-K through gray. Both the technical skills, because of course you need to acquire those technical skills, so things about conceptions, understanding how to solve engineering problems, but also the professional skills, knowledge, and abilities associated with engineering, both formal and informal. Outlooks, perspectives, ways of thinking, knowing, and doing. So I think ethics really comes into many of these. I won't go read through these, but ethics comes into many of these, and really probably all of these areas, right? So it's part of the acquisition of deep professional skills. It's part of the outlooks, perspectives, and ways of thinking, knowing, and doing. It's part of the development of identity as an engineer to understand ethical practice, and the norms and standards of what engineering ethics means. And so all of those are fair game within my programs. I have a number of programs. There's the Research and the Formation of Engineers program description, the Research Initiation Engineering Formation. I'm not going to talk about RED, Revolutionizing Engineering and Computer Science Departments, but that, I've mentioned that. I might mention that in my second comments. Career awards, workshops, supplements, etc. And here are the current elements. Again, they align with the PFE initiative. The various bullet points are related to this. And again, ethics really fits within basically all of these different categories. It's how you frame what you're talking about. But ethics as a part of engineering really fits within all this. So I'm going to talk about two particular programs I run and then a third one because they have different flavors. My programs are all foundational, exploratory stage research. So I don't fund projects that are primarily design and development of educational approaches. I'm looking at the projects look at the fundamental issues. And so there were some suggestions this morning, and I should have written down, but one of the groups had some things there about understanding ethics and how it's developed, if I remember correctly. That would fit in the program. The 5 categories of interest, those are the same things I just showed aboard. 300 to 350K for 3 years. These are unsolicited proposals. There's a program description, but I like to point out there's no long solicitation. You need to follow what's now called the PAPPG, the PAPG, no longer the GPG, no longer the Grant Proposal Guide. And the PAPPG stands for Proposal Award. No, it's PAPPG, Proposal and Award Procedures and Processing Guide. I think that's what it is. typically, this says 300 to 350, you know, up to 400 is sort of a typical. If you're going to go above 400, then you need to talk to me about it. But again, and there's a lot more guidance that I can give you individually or specifically. But basically, just remember that these are research projects. And so if your project is primarily about design and development of a curriculum, evaluating a curricular approach, then it probably does not fit as well. But I'll tell you where to send it. Proposal deadlines, there's one coming up January 20, whatever the 4th January this month is. So coming soon. Research initiation and engineering formation basically is the same as RFE with one addition. So the sameness is that it's also the same kind of research topics, everything applies. This is designed for those engineering faculty who do not have experience or the expertise to do engineering education research, but want to. For various reasons, you want to start to develop a portfolio around this. And so, you know, there's a requirement that you must not have received engineering education funding in the last 3 years, but in practice, you really should have little to no experience in engineering education research. That's actually part of the review criteria, is for the reviewers to look at, is this going to expand the community of engineering education researchers? And what you do is your co-PI is a mentor who does have the expertise. And so a part of the research proposal is the mentoring plan by which you, as the engineering faculty member, will learn how to do engineering education research. And the paradigm is as follows. You get this 2-year REEF project. At the end of that, you know more about what you're doing, and you can write an RFE proposal, again, with your mentor as a collaborator, because honestly, you know, 2 years, you may not, at that point, have learned enough to write a full proposal on your own. But you can take a more collaborative part of writing the proposal and designing the research than you did with the REEF. And then after you have that REEF, that's now been 5 years, you've got your PhD in engineering education by virtue of doing this work, and now you can still work with your mentor as an equal collaborator if they provide expertise you don't have, but you could, you know, write a proposal and run a research project on your own. So that's the idea behind the REEF solicitation. Proposal deadline last Thursday in February annually, so there's one of those coming up. Now, if you have a design and development project, and I saw a lot of these where there's ideas for new curricula, new approaches to engineering ethics education, what you want to look at is I use EHR. So this is a program, it's fairly complicated in terms of the tracks it has, but really what we're talking about here for these sort of design and development of curricula that you're talking about is the engaged student learning track. And there's 2 different approaches, exploration and design and development and implementation. That just depends on the scale of where you are right now with the development. I do want to point out that all NSF projects, including I use EHR, needs to have knowledge generation as part of it. So it's not sufficient to just say, we're going to develop this curriculum. We're going to develop this curriculum and we're going to evaluate it and learn something about teaching ethics as a result of doing this. Okay, so keep that in mind as you're going through these. The solicitation has actually, I believe, has expired at this point. I mean, there's no reason for me to believe that they won't reissue it. There's just no deadline dates. I think, as someone pointed out, there was a deadline date yesterday, I think. But obviously, that's over. So, so look for it. I mean, the typical dates were fall for the exploration and design proposals for both tracks, and then January, early January for the development implementation tracks for types for both tracks. Okay, so those are the NSF programs. That's really, really quick. I just wanted to make you aware of these, and I'm certainly glad to talk to you about any of these. I'm not actually a program officer for IUZHR, but I can tell you something about it and then direct you to the people who you could talk to more specifically. Okay, with that, I'm going to take off my NSF badge. Setting it down, I'm no longer speaking as an NSF program officer. So I would like to challenge this group in that I don't think, from what I heard, I don't think we're being radical enough in what we're doing. So Derrida talks about the absent presence in language and what we say. And so I've been listening to the absent presence in what has been said. And the absent presence is that which is not said, but which is there and is present. And what I hear still is, in many ways, a dichotomy still, even among this group, perhaps, between engineering education and ethics, just those terms. I hear people talking about, well, there's engineering education and there's ethics education, right? I've heard people say things about, for example, there's a comment about industry hiring the best engineers without regards to ethics, right? And so to me, what's missing there is that connection. I was not surprised. I was interested. It was very interesting to me that the response to my comment this morning about faculty culture towards teaching and the teaching the fundamentals, that the responses were primarily about, well, yes, it is possible, and here are all these examples by which it is possible. And so I think I'm going to challenge you, and all of that is very important and very good, and we're building up. And this group is this group around ethics education, or engineering, the ethics part of engineering, I should say. The ethics part of engineering education is growing, as evidenced by this group and people who are not present who are doing these things. And it's great that we've got all these things online. We've got the online repository and all these ideas for doing more things. But I want to challenge this group to think about how to move beyond that to changing the canon of engineering, so that, I think as Donna said, it's not ethics and engineering, it's all engineering. And how do we change the culture of those who aren't here and who wouldn't be here? I think that's the point I was trying to make this morning. All those faculty who would never even consider coming to a workshop like this because they teach statics. And I've been teaching statics for 30 years, and I know how to teach it, and I've got the problems down, and I make sure my students know how to resolve those forces. How do we get those faculty to rethink how they think about what engineering education actually is, so that all of these things, ethics, and all the communication, all those other things that sort of get lumped together as professional skills become an actual part of engineering education. And again, a reminder that the RED program, which I skipped over here, all of those projects have some aspect of that in their programs where they are actually changing what it means to teach engineering and including all of those things, ethics, to social justice to some extent in all of them. If we want to focus on ethics, social justice, again, I would point you to the University of San Diego, whose project is changing the engineering canon to be about humanitarian engineering, social justice, and peace. And so the energy here has been wonderful, and I hope you take that energy and take it to the next step.
And yes, I'm going to put my NSF badge on. I have some brochures. If you are familiar with this program, I ask you not to take one because I only brought this handful. There's a couple more on the table. So Elliot opened the door for the program that I am the program officer for at NSF, Cultivating Cultures for Ethical STEM. And really at the heart of this program is this question of how do we as scholars, researchers, change cultures? So if you're struck by Elliot's challenge, please come look to the Cultivating Cultures for Ethical STEM. But before going there, I want to introduce myself because I'm a science and technology studies scholar who's been on the margins of the engineering ethics conversation because of Tom Leitzinger many years ago. But I've been watching your community from a distance, and I have the good fortune now to be the program officer for the Cultivating Cultures for Ethical STEM. But I too, like Elliot, am impressed with the energy in the room and how the community is growing. And particularly that it's at one point, and I think Tom can validate this, it was just some older gentlemen in the room talking about it, and we now see that it's much more diverse. So I congratulate you for that. So how do I, this, yes? Oh, magic. So CSTEM is a cross-directorate program at NSF. All of the directorates are involved. So engineering's involved, education's involved, computer and information science, geoscience, biology, education, and even the Office of International Science and Engineering. So it's a collaborative program. I happen to be the lead. I'm sometimes ushering cats, as Elliot can attest to. But we come together as a working group to review, to encourage PIs, and ultimately to award 6 or 7 proposals a year. So what is CSTEM? Some of you may know its former predecessor, EESE. It changed in 2013. 2014 was the new solicitation, where NSF decided that they wanted a stronger focus on research. So if you are thinking about applying to CSTEM, please keep in foremost that NSF wants a research. Before, the EESE program was focused more on pedagogy, so that's the big difference, and also the age or the education level. Before it was graduate, now it's the door is open. But so CSTEM funds research projects that identify factors that are efficacious in the formation of ethical STEM research in all fields of science and engineering that NSF supports. So we are looking for proposals that raise various questions, from what constitutes ethical STEM research and practice, and which cultural and institutional contexts promote ethical STEM research and practice, and why. Do certain labs, communities, workplaces have a culture of academic integrity? And what practices contribute to the establishment and maintenance of ethical cultures? And how can these practices be transferred, extended, and integrated into other research and learning settings? And this is from the solicitation. It's fairly general. It's not necessarily focused only on engineering, but it's to be a provocateur, to get you thinking about how can we change and what is occurring within our cultures of ethics in whichever particular STEM you're working in. The background or the backdrop for this, the idea is that the research that this program creates will feed universities' programs of responsible conduct of training. As you know, it is a federal requirement that a grad student or postdoc, grad student or undergrad who gets NSF funding or NIH funding undergoes training in the responsible conduct of research. As some of you know, different universities take different approaches to it, and that can be debated in another context, and I know it is. But our goal with CCE STEM is that the research we produce will inform those conversations, and whether they will help nudge the training of responsible conduct of research, or whether it will provide materials, and then ultimately that the materials you produce will also be put on the online ethics center, which I know Fraser will talk about later. So my challenge to myself, and this is probably without my NSF badge, I'm not going to be quite the provocateur that my colleague was, but I sat here yesterday saying, okay, what do I hear in the conversation that's occurring that could be a research question or a nugget or a foundation of a proposal that could come to CSTEM? And so I came up, and actually I cut my list down. I only did 2 slides of questions, but I had fun listening to your conversation. And these are just questions that are bouncing off of your conversation yesterday. As I said, this is not an NSF official saying, I want these questions, but it's more to help you think about, once you read the solicitation, the sort of questions we're interested in. So yesterday I heard a question about values. And what are the values embedded in our design, practices, processes, and decision-making, and their impact on ethical choices, decisions, dilemmas, and challenges? I tried to write these vague enough so you could look at it for computer engineering or civil engineering or whatever community you happen to be working in. What are the everyday ethics of a community lab workplace? What supports, challenges, reinforces, and erodes them? And I'm hoping you're hearing some of maybe your ideas or your colleagues' ideas echoed here. What are the ethical needs of younger professionals, practitioners, engineers, and scientists? And what is the role of managers of STEM in the cultures of ethics or ethical values of community lab work and the workplace. And I did not go do a literature research last night to see, oh, how much work has been done in these areas. So there may be, these may be gaps. They just may be gaps in your community. So they're just ideas that I heard yesterday. And the last slide that I have on this is what makes ethics integral and invisible in this STEM community lab or workplace. What is the impact on everyday ethics, professional ethics, or whatever? Because I heard that conversation where we're teasing out, is there a difference between everyday ethics and professional ethics? Of top-down and bottom-up initiatives on this STEM community lab or workplace. What sustains, extends, strengthens, develops ethics in this STEM community? What are the myths, both true and false, that are shaping and defining ethics in communities, labs, and workplaces? And how are they reproduced? What is their impact? So those were just my samples of ideas from your conversation that are all, could be foundation or underpinning research questions in a proposal. However, my challenge to you, particularly all the affinity groups, is to look at your discussion and to see what research questions are there that could be developed into a proposal for C-STEM. Then just some of the nuts and bolts, that we do standard and institutional transformation grants. And we've only done 2 institutional transformation grants, and both of those PIs happen to be in this room, so you are in a very elite group in this room. The standards can be collaborative or singularly. That C-STEM does look for comparative angle in the proposal, so that is one of the strengths that they would like to see. Maximum amount for 5 years is $600,000, and that's usually the institutional transformation, and the typical 3-year award is up to $400,000, whereas the average award is $275,000. Recognizing we don't have the biggest budget, but actually the budget has grown. If you look at the history of ethics at NSF, that it is the largest budget at the moment at NSF that we've had. And our due date is the 15th of February, so it's coming up very quickly. If you're not familiar with these websites and you want to tackle NSF, they're good places to start. Research.gov, fastlane.nsf.gov, as well as nsf.gov, where, and I apologize that I did not update this slide to the new name because the new name is just official as of this month. But that too can be found on the NSF website. And then my last slide is blank for you to fill in the research questions from your affinity groups. So thank you.
Last but not least, Norman.
Thank you, Bill. I don't have slides, so we'll all suffer. We don't have security badges at ASWE. We just have proximity badges, so I'll put on my little data watch so that I, too, can put on and take off my badge. Quick correction, the little salmon-colored or pink sheet with the email addresses. My email address is wrong. If anybody does want to send me something, it's just n.fortenberry. So if you delete the first N, O, R, M, and A, just that N dot at the bottom, and that's correct. So that's fine. I was asked to address how the topics discussed thus far fit into overall efforts to improve engineering education, and then what are possible next steps, including possible initiatives. Fortuitously, I was made aware yesterday of an article that appeared in Undark, which I've never heard of before, but it's on the web. Apparently, it's an online magazine, but this is all about Before the Bridge Falls Down. It's January 10, 2017 by Bianca Vasquez-Tones. Engineers faced a host of ethical challenges like pressure to cut corners and hide mistakes. Who's educating them about professional responsibility. I thought it was kind of nice that that came out right as we were discussing the topic. And it's a nice magazine because they have embedded videos, at least at the top. So, this article, along with posters, background reading, and various discussions, point out several relevant challenges, to my mind. An overcrowded engineering curriculum makes separate standalone ethics courses difficult. Moreover, individual ethics courses risk marginalization, while modules in existing courses risk dilution and necessitate negotiations with faculty peers and other institutional constituencies. There is low faculty knowledge, comfort, and facility with teaching ethics, engineering faculty knowledge. Co-teaching, linking engineers with people in philosophy and other disciplines, is time and labor intensive, and particularly in the context of public universities can be quite expensive. Facilitating learning at scale, both larger classes and across classes, is a challenge. There are a wide variety of foci with respect to concepts, values, and virtues and skills, individual as well as organizational, big versus everyday, traditional engineering tasks, as well as engineering supervision and management. There are a variety of ethical situations to be addressed, including ethical challenges, ethical decisions under uncertainty, and ethical dilemmas. Some would say that ethics is doing the right thing and doing the thing right as individuals and as parts of various communities while considering impact on clients, individuals and communities, immediate community, end user, and broader society. However, right is a community brokered reality tempered by individual standards. But we all belong to multiple communities defined by geography, home institution, organization, subunits within our institutions, industrial sector, disciplines, demographics, et cetera. And there can be significant challenges when we move between communities and thereby between cultures. So given all that, what can we do? Larry Schumann is editor of ASE's online journal Advances in Engineering Education, AEE, and he's thinking about a special issue on this topic, and he'll talk to you about that. But having thought about this and related topics, I have two modest proposals, with apologies to Jonathan Swith. These proposals are my own thoughts. At this point, we take off the ASEE badge, and do not represent the policy positions of ASEE. My comments may, actually, next to Elliot's, they won't be that shocking. And I admit may demonstrate ignorance of practical implementation challenges, but they represent directions that I believe we have to move in. And I acknowledge the greater diversity of U.S. and global higher education, and so my suggestions will apply to a greater or lesser extent based on your local circumstances. But ultimately, I think we're spending too much time tinkering around the edges, when what we need is a movement toward much more radical change. My comments will be brief in hopes that, well, actually less brief now because I've been taking notes in real time, in hopes that there will be additional time during the Q&A to enhance your and my understanding of what it is I mean. All right, so first, how can engineering faculty gain the time and space to either work with peers inside and outside the discipline well-versed in philosophy and ethics, or personally acquire sufficient knowledge to be more than dilettantes? I believe we need to be much more purposeful and directive about the graduate or postdoctoral preparation of future engineering faculty and the induction of new faculty. Let's acknowledge that everyone with a PhD teaches to some degree and actively and deeply prepare them for that role. We need to move engineering departments to a team concept, no longer requiring each individual faculty member to be expert at an ever-expanding number of expectations. Just as we currently hire engineering faculty for their specialized knowledge of thermal fluids or mechanics or semiconductors, we need to more broadly hire engineering faculty for their specialized knowledge of ethics and communications and other professional skills. And while we can collaborate with faculty in other disciplines, we can and maybe should have engineering faculty with such skills in line with Boyer's definition of pedagogic content knowledge. Second, how do we address the variety of ethical topics and frameworks within an already crowded curriculum? Just as many campuses have a design spiral and an analytic spiral within the curriculum, I believe we should similarly have an ethics spiral that winds its way through various courses over several years, allowing a variety of different ethical topics and frameworks to be addressed. This implies we need to incorporate ethics into existing courses. Ethics is integral to engineering learning and practice. We can't claim to be teaching students to be engineers if we can't accept that. Of course, we also need to do a much better job of incorporating a whole array of professional skills and not simply throwing them in without deep thinking about how to promote learning. One of my personal pet peeves is people who throw a group of students together and say, okay, you're a group. And from this process, we expect you to learn how to operate as a group without any instruction or guidance. We also need to adopt broadly pedagogies such as problem-based learning that facilitate the learning of ethics and other topics in deep yet time-efficient manners. Ideally, this would happen in concert with working much more closely with industry or with EPICS-like service learning activities, such that authentic ethical challenges can be surfaced and addressed in real time. Aalborg has shown that we can do that. Ideally, we would also engage outside of our local contexts. We are supposedly preparing students for global practice. Should remember that. Obviously, new ways of teaching imply a need for new, more authentic forms of assessment. Now, the rubrics that Larry mentioned are beginning to address this issue, but we need much more work because using old assessments with new teaching is a recipe for frustration and failure. Finally, or almost finally, we need to acknowledge that 4 years, really 4.5 on many of campuses, is no longer sufficient time to adequately prepare someone to enter the workforce as a full-fledged engineer. Now, as an aside, 4 years may remain sufficient for someone to enter a de facto apprenticeship working under the guidance and tutelage of a more senior engineer in a large department. But most engineers work for small and medium-sized firms. They are not an engineer, but they are the engineer, or one of very few in the company. As a separate aside, much of this portion of the discussion is affected by the professional placement of engineers versus other professions. How engineers are, in general, overwhelmingly employees versus independent practitioners, but that's a whole separate day-and-a-half conference. To squeeze in the extra time needed, we can either encroach on some summers, extend the undergraduate curriculum, or adopt Jim Duderstadt's idea of treating the undergraduate years as simply a major, in quotes, that prepares students for entry into one of a variety of graduate professional school options or other career paths. And yes, I understand there are significant financial, political, and other implications associated with that set of options. Alternatively, we can have a really painful discussion about what really are the fundamentals and allow students much greater differentiation and specialization within current degree programs. As an example, MIT's Department of Mechanical Engineering, Course 2, does this with its 2A option. So, all right, so for those of you MIT speak, it's numbers, not words. Course 2 is mechanical engineering, so 2A is an option within mechanical engineering. The 2A option, more students now take the 2A option than the base Course 2 option. Course 2A allows students to largely shape their own curriculum by selecting 6 concentration courses and 4 electives among the 16 courses they take in their junior and senior years. So that essentially gives you 10 out of the 16 are selected by the student in concert with an advisor, but selected by the student, and that's incredible flexibility. So with that, I will stop. Thank you.